A study by the U.S. Department of Energy found that converting retiring coal plants to nuclear could save capital costs significantly. TerraPraxis is one organization working on this exact goal. And for more insights, I'd like to bring in Eric Ingersoll, who is the co-founder of TerraPraxis. Eric, why repower coal plants for advanced nuclear?
Repowering coal plants with advanced nuclear allows you to get all the benefits of a coal plant, but without emissions. The challenge is that there's a lot of coal plants that we need to repower. Over 260 gigawatts in the US and 2 terawatts globally. So we really need to find a way to make this process fast and low risk and easy for the developers and the owners of the plants.
How do we address the deployability challenges of nuclear and do it through the repower model?
Well, the repower model is addressing this two main ways. One is through innovating the design and delivery of the plant itself and working with a consortium of supply chain partners and customers to make sure we get the requirements right to fit into a low-risk, commercially financeable developer model. The second is attacking the complexity and duration and cost of actually getting a plant licensed and permitted. And there we're working with our partner Microsoft to use AI to help generate license applications, to fill out the application and write it, and there'd still be humans in the loop. And we're also using that, looking at how to use that same technology for things like environmental permits and other very labor-intensive and expensive and slow processes to produce many 100-page documents that are required to get these projects through the process.
This is fascinating that you mentioned the consortium. You all have a lot of partners. You mentioned Microsoft, and you mentioned what is really cool, the AI component of it. So can you talk specifically about how the AI works into this platform?
Yes, so it's interesting, AI is actually driving the demand for this. So what we found is that the tech companies that have to build tens of gigawatts of data centers every year are finding that they can't source the power for those installations. So they're very interested in finding a way to deploy nuclear power that is fast and cheap and fits within the development timelines of their projects, which nuclear currently doesn't. So being able to use AI to support the licensing process through large language models and generative AI, what you do is you train those AIs on existing good license applications, and then you provide them with a new data set for a new site, and they can generate a draft license application for you, hundreds of pages in an hour or two. So this is an incredible transformation of the cost and speed of this process. And we think this is one of the key things to making nuclear into a broadly available resource for these rapidly growing industrial sectors. The other part of AI is in the design process. And generative AI is already being used by architects and engineers when it's appropriately trained to do the complex engineering of very large systems. The rules for nuclear electrical systems and the rules for nuclear plumbing and all of these things are very well defined. So it's actually a fantastic application for a rules-based design tool. So if we can combine AI for application and permits and AI for design, we think we can achieve, we can take the risk and cost that's at the front end of these projects and shrink that down to something that will make them very attractive for investors and for the customers and developers.
Eric, thank you for your insights, and thank you for joining us today. For more insights like this, join us on the Enlit community.